Okay, we're going to talk today about what a reference angle is, how to find a reference angle, and to find the area of an oblique triangle. It's super easy, I promise. But these little rules right here, you guys need to know. You will not be given this stuff on your quiz. So you need to know how to find the reference angles depending upon where they are, the angle that's given, where it lies on the coordinate plane. What you should remember, 100%, very, very positive, very, very important for you to remember is that your reference angles are always going to be acute and positive. That doesn't make any sense right now, but it will in a second. Let me explain to you what a reference angle is, then we'll talk about how to find it. So if you have an angle, okay, say they tell you that theta, so your angle theta, is 284 degrees. Okay, so remember, this is 0, 360. This is 90 up here, 180 over here, 270 down here. Where is 284? In between, in which quadrant? It's in quadrant 4, right? If I start here on the x-axis and I go all the way around, then this angle is somewhere over here. So 284 degrees is that blue angle. Your reference angle, the way that you always get something that's positive and acute, your reference angle is drawn from the terminal side, this is the terminal side, to the x-axis. So my x-axis would be up here. So this right here is your reference angle. So the first thing you do to find your reference angle is you have to get in your mind a picture of where the given angle is. Is it in the first quadrant, the third quadrant, or whatever? Once you figure out where it is, then you use these rules over here to decide what the reference angle is. So if I had 284 degrees, you guys just told me 284 is in what quadrant? It's in quadrant 4. So if I have an angle that is in quadrant 4, what is the rule? How do I find what the reference angle is? You take 360 minus the angle, which is 284, and what do you get? What's 360 minus 284? How much? 76 degrees. Now let's check our answer there. Is 76 degrees a positive acute angle? Yes. So your reference angle to 284 is 76 degrees. So if you look at if I told you I had an angle right here, this yellow angle, all right? The yellow angle is 38 degrees. So my given angle is 38 degrees. What's the reference angle? What's the rule say? Where is 38? In what quadrant? It's in quadrant 1. So what's the rule in quadrant 1? It's just 38 degrees. Your reference angle is the same. Is that a positive acute number? Yeah, so think about it. If I was going to draw the reference angle, I'm going to use green. You draw the reference angle from the terminal side down to the x-axis. It's the same exact angle because it's in the first quadrant. Because remember, anything in the first quadrant is positive and acute.
Can it be negative?
We'll talk about a negative one. So look at the next example. I'm going to do example C. We'll say theta is negative 352 degrees. All right, so on your quiz, on your homework, they're going to say to you, find the reference angle for. Guys, do you know off the top of your head where 5 pi over 3 is on the unit circle? Can I figure out what that is in degrees? Absolutely. So if you start off in radians, your answer should be in radians. At the end, we'll convert it back. But let's figure out where that is on a coordinate plane. So pi goes on the bottom, 180 on top, correct? So 3 goes into 3 one time. 3 goes into 180 60 times. And my pi's cancel out, right? So 5 times 60 is 300 degrees. So the given angle that they're showing us is 300 degrees. So let's think about where 300 is. Some of you don't need to draw this, which is fine. You don't have to. I'm just showing you how visually you can help yourself out. Where is 300? It's in quadrant 4. You guys agree it's over here in between 270 and 360, correct? So what is the rule? If your angle is in the 4th quadrant, what's the rule? 360 minus 300, and I get 60 degrees. Check that answer. 60, is that a positive acute angle?
Yes.
Yes. But we started off in radians, so your answer should be in radians. So just convert it back. 180 goes on the bottom, pi goes on top. Well, zeros will cancel. 6 goes into 18 3 times. So your reference angle is pi over 3. So I look at example B. Okay, what do you notice about 870 degrees? It's greater than 360. It's bigger than a circle. So let's just figure out some coterminal angles that would be between 0 and 360. What would I do with 870? Okay, subtract 360. It's going to bring us back to the exact same spot. And I get what, 510? Well, that's still bigger than a circle, so subtract another circle. Brings me right back to the same spot on a quarter plane. What's 510 minus 360? 150 degrees. Is that in between 0 and 360?
Yes.
Yeah. Okay, so let's figure out where that is. 0, 360. Again, you don't have to do this part if you can visualize it. Some of us can't. So where is 150 degrees? It's over here in quadrant 2, right? What's the rule for quadrant 2? How do you find the reference angle for if something's in quadrant 2? 180 minus the angle. So 180 minus 150 gives me what? 30 degrees. Is 30 degrees a positive acute angle?
Yes.
Yes. We started off in degrees, so we ended up in degrees. Perfect. Good job. All right, now a negative. A negative's a tad bit different, but we attack it the exact same way. You don't have to draw this part, but I'm going to here. What does that negative sign mean? It's the opposite direction. Good, very good. Remember that negative is just direction. So if I was going to draw this, negative 90 would be here, negative 180 here, negative 270 here, and then negative 360. So think about it. When I draw negative 352, it ends up being in what quadrant? It ends up being in the first quadrant, right? You guys see that? So visually, you guys see that. Okay, so just like when we were over here, we said 870, we found some coterminal angles. We just subtracted 360 till we found something between 0 and 360. What could I do with negative 352? What could I do here to make it a positive? What could I add? I could add a whole circle, right? I could add 360 to this, and I get 8. You guys agree with me? Because all we're doing here is we're adding a whole circle. So if I go here and I add from this point all the way around, I end up with this little piece here. This is 8 degrees. Well, you guys told me that negative 352 is in the first quadrant, right? So if negative 352 is the same as positive 8, what is my reference angle? 8 degrees. Because it's in what quadrant? The first quadrant. So if you have something bigger than 360, just keep subtracting till you get something between 0 and 360. If you have a negative, just add. Say I had like negative 900. I'd have to add 360 more than once, right? But that's okay. Yes, sir.
Quadrants don't change if it's negative, right?
Correct. Yes, ma'am.
You don't have to draw that, right?
No. I personally have to draw that because sometimes that, just carelessly when I don't pay attention to stuff. But that's our reference angle stuff. On your web assign, I think it's like 7 through 16. They ask for exact values. You have to use reference angles. You guys can just cross that out because we're going to do that in a later session. So 7 through 16 on your web assign, you can skip. I need to make a little correction here. Say it again.
Which question?
I think it's 7 through 16, but we can look. This should say 2 sides. And this should say angle. I realized this morning after I uploaded it that I read it backwards. So, back in geometry, when you guys had geometry, you were paying very close attention in geometry, you had a triangle and they said, find the area of the triangle. Does anybody remember your area of a triangle formula?
Oh, yeah. 1/2.
1/2, good. Base times height, or base times height divided by 2, right? Well, what do you notice this triangle has that this one does not?
A right angle.
A right angle, very good. This red triangle is called an oblique triangle. All right, we're going to find the area of an oblique triangle. And oblique triangles don't have right angles in them. So there's a different formula to use. You're still going to use the 1/2. I just like to write divided by 2 instead of times 1/2. But what you need to find the area of an oblique triangle is you need 2 sides and an included angle. What does it mean if the angle is included? It's in between. So look, I have a side here and I have a side here. Do I have the angle in between those 2 sides? Yes. So all you do is take one of the sides and you multiply it with the other side, and then you multiply it by the sine of the included angle and divide by 2. You can do this in your calculator. You can either hit 3 times 10 times sine 20 and then divide it by 2, like enter divided by 2, or put the entire numerator in parentheses and then hit divided by 2. But just, it's the 2 sides that they give you times the sine of the included angle. What do you guys get? So you get something like 12.9 something. All right, now we're talking about area. So this is centimeters what? Squared. All right, it's really important, guys, on your quiz to read the directions. Some of the directions say round to the nearest whole number, round to the nearest foot, round to 2 decimal places. I'm going to take off points if you don't follow those directions. If you're talking about length of something, you should have centimeters, meters, yards. If you're talking about area, you should have centimeters, yards, meters squared, those sorts of things. Now, you can have this question a couple different ways. They could ask for the area of this triangle, and they could say this side is 10, this is 15, and this is 12, and they give you this angle is 47 degrees. What information do you need, and what do you not need in this problem that I just gave you? You don't need the 12. There's no hypotenuse because it's not a right angle. But why don't you need the 12? You need 2 sides and the angle in the middle. If I were you and I had a triangle that had a whole bunch of stuff like this, I would go just like this. I would say, okay, I have a side, and I have the angle in the middle. Do you see how the angle is in between the 2 sides? So you would set this up, guys. You don't need that 12. You would say 15 times 10 times the sine of 47 divided by 2. What do you get? 54.85, and I didn't say anything, so we'll say units squared. Okay? Fair enough. What about if you had a triangle like this? And again, you guys are smart enough to figure this out, right? An oblique triangle does not have any right angles. Does that kind of look like it has a right angle? Yeah. But I cannot just assume what needs to be in the corner there if you think it's a right angle. Gotta have a box. All right, so say they tell you that this side is 17 yards. This side is 25 yards. Angle B is 96 degrees. Angle C is 38 degrees. What do you need in order to find the area of this triangle? You need 2 sides, right? And what? The angle where? In between, which would be A, correct? Can you figure out that angle in between? How come? You can say 96 plus 38, right? What is 96 and 38?
134.
It's 134. And how many degrees are in one whole triangle? So you'd have to say 180 minus 134, and you get what? 46. So you could say this is now 46. Now do you have the information you need to find the area? Yes. You would say 17 times 25 times the sine of 46 divided by 2. Which practice that in your calculator. With 17 times 25 times the sine of 46 divided by 2.
Excuse the interruption. Antonio Jimenez, please report to Student Services Office. Antonio Jimenez.
So 152.9 yards squared. Sarah just asked a really good question. She said, is it in the formula, is it always going to be sine? Yes. It's always going to be the two sides that they give you and then the sine of the angle in between divided by 2. All right? You guys all right?